It's the same reason a ball you throw eventually falls back to earth. That's like a two-story building. To compensate for this massive drop, snipers have to aim significantly higher than their target. Their scopes are designed with incredibly precise adjustments, allowing them to dial in the exact amount of elevation needed. They use something called a ballistic chart or a ballistic calculator, which tells them exactly how much the bullet will drop at any given distance. So, they're not aiming at the target, they're aiming at a point high in the air above the target, letting gravity do the work of bringing the bullet down right where they want it. This is the first and most fundamental reason a bullet's path is a curve, an arc, not a straight line. Snipers have to become expert meteorologists. Is the wind blowing from the left? They have to aim to the left. From the right? They aim to the right. This correction is called windage. It's a skill that takes years of practice to master, as wind is often inconsistent, changing speed and direction between the sniper and the target. It's a constant, invisible river that the bullet must navigate. Now, let's get into some really mind-bending stuff. Did you know the rotation of the Earth itself affects a sniper's shot? This is called the Coriolis effect. Because the Earth is a spinning sphere, any object traveling over long distances across its surface will appear to be deflected. In the northern hemisphere, this deflection is to the right. In the southern hemisphere, it's to the left. This effect is very subtle for everyday objects, but for a bullet traveling a long way, it becomes significant. For an east-west shot at 1,000 yards near the equator, the Coriolis effect might move the bullet about 3 to 4 inches. It might not sound like much, but in the world of precision shooting, 4 inches is the difference between a hit and a complete miss. But wait, there's more. The bullet itself has its own unique behaviors. This spinning motion, however, creates another effect called spin drift or gyroscopic drift. For most rifles, which have a right-hand twist in their barrels, the bullet will drift slightly to the right. Over 1,000 yards, this can add up to another 10 inches of sideways movement that the sniper must account for. So now they're not just correcting for gravity and wind, but also the bullet's own tendency to curve due to its spin. Air density, which is affected by temperature, altitude, and humidity, creates drag. Thicker, denser air slows the bullet down faster, meaning gravity has more time to pull it down, increasing the bullet drop. At high altitudes, where the air is thinner, the bullet will fly faster and flatter. Then they read the wind. It's a 7 mph crosswind from their left. They have to subtract a few inches from their leftward aim to account for that. Finally, they check the temperature and altitude. The bullet's journey is a graceful, complex ballet, influenced by the planet, the weather, and its own spinning motion. So, the next time you see a sniper in a movie, remember that the straight line you see from the scope to the target is a complete fiction. The real shot is a testament to the unseen forces that govern our world and the incredible human ability to understand and master them. The bullet doesn't fly straight because the universe is far too interesting for that. If you found this as fascinating as I did, make sure to hit that like button and subscribe for more content that unravels the science behind the world around us.